All right, 8th graders, your last video was about solving quadratic equations by factoring. And so now we're just going to solve quadratic equations by two other methods. One of them is going to be completing the square. So we're going to start with that. It's called completing the square. If you remember from our last video about factoring, there's a thing called a square of a binomial, which looks something like this: x squared plus 10x plus 25, let's say, equals 0, all right? And if we solve that by factoring, that's a square of a binomial because that's a square, and that number is double the product of the square root of that and the square root of that. Okay, so it comes out to x plus 5 squared. Now we've already done these. Equals 0. All right, and we learned when we solved by factoring, when we factored, it would have been more like this. And you would have set each one of these equal to 0, so the answers would be -5 and -5, same answer. Okay, well, we can use a more traditional method here. Go back to, last year, when you just say once upon a time there was an x, it was added to 5, it got squared, we square root to undo squaring, we square root, and we get x plus 5 equals, square root of 0 is 0, fling the 5, x equals -5. Okay, we kind of already did this, but let's say we get a problem. We're not going to be able to factor it. We'll do the exact same problem, except with a slight twist. I'm just going to say x squared plus 10x plus 20, I don't know, 23 equals 0. Okay, and then we're like, oh man, it's so close to a square of a binomial. And I kind of wish that number was a 25. Man, do I wish that number was a 25. So what I do, and this is how I like to do it. Some people just like to add 2 to that side and add 2 to that side. But what I sort of prefer to do is clear a space for my wish for area, fling the 23, and we get that. Now, what did I wish was in this space? I would make like a little smiley face and say, what do I wish was there? I wish there was a 25 there. Okay, so now this equation is in balance. So what I can do is I can add a 25 there. Now, how did I come up with the number 25? Well, I mean, we knew it from the previous problem, but it's always half the middle term, which is 5, and then squared. So plus 25, okay? Now, if I just randomly add a 25 to this side, I got to do it to this side too. Now, I've got my square of a binomial, and that's x plus 5 squared. This side comes out to, not to 0, but to 2. It's okay. Once upon a time, there was an x, got added to 5, it got squared, so we square root, which is the undoing of squaring, and we square root that side, and we get x plus 5 equals, it's a terrible 5, looks like an S. X plus 5 equals the square root of 2. Now all I got to do is fling the 5. X equals -5. Now there's a little twist here. If somebody asks you the square root of 2, well, first of all, it's some irrational number, 1.4 something, something, something. But negative that times itself is also 2. So it's the positive or negative square root of 2. And we're going to let you leave it in what's called radical form. You can just leave it as a square root of 2. You don't have to find out what the square root of 2 is. You just leave it like that. Okay? That's called completing the square. We're going to do another simple one really fast. All right? And we'll go... let's see, we'll go x squared, we'll go minus, and we'll go 14x go, let's see, minus 7 equals 0. Okay, and you're like, oh man, I don't know, probably not going to factor, so I'm just going to write this. I'm going to fling my 7 over, positive 7 over here. I got my wish for space. Half of negative 14 is negative 7. When you square negative 7, you get positive 49. If I add 49 to that side, I'm going to add 49 to that side. This time, my square of binomial has a negative term, x minus 7 times x minus 7, or x minus 7 squared, equals 56, square root, x minus 7 equals the square root of 56. I'm going to be a little lazy and, well, no, I'll go ahead and rewrite it. X equals positive 7 plus or minus the square root of 56. Now, on a test, you don't have to do what I'm about to do, but if you want to be really fancy, you could split the 56 into square root of 4 times square root of 14 and go 7 plus or minus 2 radical 14. Don't split it into like 8 and 7 because they don't have square roots. Split it into something that's got a square root, like 4. All right? And either one of these answers is fantastic for right now. That's completing the square. Now, with a little twist, all right, one little twist. So I'm going to cover this up. I'm going to erase this. If there's a factor that can be pulled out of all of them, by all means, slurp it out. You guys have already learned how to do that. But if there's something like 3x squared, I don't know, plus 2x minus 5 equals 0. I don't even know if that factors. Maybe, maybe not. But this 3 makes it really unpleasant, really uncomfortable. So what I'm going to do is I'm going to first fling my 5. Then I'm going to divide everything by 3 to get rid of that 3 because 3 doesn't have a square root. So I'm going to go x squared plus 2/3 x equals 5/3. Now my wish for space, it's the same. I take half of that. What's half of 2/3? 1/3. And then what's 1/3 squared? 1/9. So I'm going to add 1/9 there, and I'm going to add 1/9 there. And I'm going to get x plus, now remember, this term is always the square root of that. So x plus 1/3 squared. Here I need a common denominator. So I get, let's see, 15. Oh, this is going to come out. This is pretty cool. 15/9 plus 1/9. That's 16/9. I'm going to just be lazy and not rewrite the step. That's 16/9. And then I can square root. And I can square root. And x plus 1/3 equals, the square root of 16/9 is easy. 4/3. All right. But remember, it's the positive or negative 4/3 because negative 4/3 times negative 4/3 is still 16/9. I'm going to fling my 1/3. I get negative 1/3 plus or minus 4/3. Then I just do the math. Negative 1/3 plus 4/3 is 3/3, which is 1. Negative 1/3 minus 4/3 is negative 5/3. Okay, that's completing the square. I got one more method to show you. You guys are good at this. It's really easy. Heck, let's just do the same problem, all right? So we'll do the same problem here. I'm just going to erase the work. And we're not going to, I don't know what I'm saying. We're going to use the quadratic formula. And I know what I said we're not going to do. We're not going to derive the quadratic formula like we did in class. We're just going to use it. You guys should all remember the song. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's in the form ax squared plus bx plus c equals 0. So in this case, a equals what? A equals 3. B equals 2. Okay? Now when I say negative b, it's going to be negative 2. But if it was a negative, then I would say positive 2. All right, c equals negative 5. Okay. Just going to plug numbers in. It's really easy. Just take these numbers and shove them into the formula. So x equals negative b, so negative 2, plus or minus the square root of b squared, so 2 squared, which is 4, minus 4, it's part of the equation, times a, which is 3, times c, which is negative 5, all over 2a, so there's a, 3, so 2a is 6. Okay, we're just plugging numbers in formulas. This is really easy. So x equals negative 2 plus or minus. All right, now, the most common mistake people make is getting the sign right under the radical. So here's what I do. This first part I just kind of cover up, or I just leave it there. It's a 4, and then it's negative 4 times 3 is negative 12, times negative 5 is positive 60. So then my sign is 4, right? I said all of this was positive 60. So 4 plus 60 all over 6. Now again, because I'm running out of board space here and I don't want to go wider shot on the camera, I'm just going to cheat a little bit and erase this. What's 4 plus 60? Duh. 64. And then what's the square root of 64? Duh. It's 8. And we solve the problem. Negative 2 plus 8, well, that's 6 over 6, that's 1. Or negative 2 minus 8, well, that's negative 10 over 6, which, if you recall, when we did the problem the other way, we got negative 5/3 because that's just reducing that fraction. So negative 5/3. Okay? That's pretty much it, guys. I mean, for quadratic formula, you just plug numbers in. Couple of things. If somebody were to ask you, well, let's do the rest of the song. Okay? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is the formula that we use when we solve quadratics. Helps you find the x-intercepts of the parabola. Really fast, because this is going to be in another test where we do all the graphing, but a parabola is what the graph of quadratics look like in the form y equals ax squared plus bx plus c. Okay, it's a little curvy thing. Sometimes it curves down. We'll talk more about why it curves down or why it curves up, but x-intercepts are right there. Okay. And right where the graph crosses the x-axis, the points where a graph, any kind of graph, parabola, line, or whatever, where the graph crosses the x-axis. And that always has a y value of 0. So if a question says find the x-intercepts, all you're doing is solving a quadratic where y is 0. Okay, so let's do one quick weird example of this. Right, so if I said y equals, we'll do an easy one, x squared plus 2x plus 20, yeah, that's good, not good, it's not a factor, equals 0. Oops, did I say equals 0? Duh. Y equals this. It's got a graph, okay? But if someone says, what's the x-intercept? Well, it's the place where y is 0. So I just plug in 0. That's it. And I solve it. It's not going to factor, so I'm going to use my new quadratic formula. Negative b, negative 2 plus or minus square root b squared 4 minus 4 times a is 1 times c is 20 all over 2a. 2 times 1 is 2. All right, negative 2 plus or minus square root. Ready? Cover it up. Negative 4 times 1 is negative 4 times 20 is negative 80. So it's 4 minus 80 all over 2. Negative 2 plus or minus the square root of negative 76 all over 2? What? Okay, here's the deal. You can't have a square root of a negative number. So it's called an imaginary number. So there is no such time when 0 works, which means y can't be 0, which means the graph of that thing would look something like that. I don't know exactly like what, but it would look something like that, meaning it never crosses the x-axis. There are no x-intercepts. So you get a question on your next test like, what are the x-intercepts? Well, if it comes out, whatever your two answers are, those are your x-intercepts. If it comes out where this is negative, there are no x-intercepts. And we'll talk more about that in the next chapter as well, okay? Wonderful. All right, that's it. All right, you guys are ready. And let me turn off the video here. You don't need to watch me erasing.